Hello, and good morning, at least for me anyway, and welcome to this in-depth series on OSPF. In this video, we'll cover some basic high-level operation of OSPF. To view the rest of the contents of the course, check the description for a link to the playlist and all the rest of the information you need. Consider subscribing and enabling notifications to know when the next video in the series is released. The goal of this course is to completely prepare you for exams such as the CCNA, CCNP Encore, CCNP NRC, or Advanced Routing and Services, and beyond. By the end of this course, you'll be able to confidently explain, configure, and troubleshoot OSPF. In this video, we're just going to go over some basics. So what is open shortest path first? What is the shortest path tree? And we'll look at an SPT example. Those of you who are already at the CCNP level may find some of this video boring, so remember the speed option and increase the speed if necessary. You can also check the description for links to more of the advanced material. Let's begin. So what is OSPF? Open shortest path first is a standards-based interior gateway routing protocol. OSPF uses IP protocol number 89. This is an important fact that you just need to memorize. OSPF version 2, which is for IPv4, is defined in RFC 2328. OSPF v3, which is for IPv6, is defined in RFC 5340. OSPF is a link state protocol that uses the Dijkstra algorithm to determine the shortest loop-free path to a destination. Because OSPF is open standard, this used to make it an advantage over EIGRP until recently when Cisco and others released the details of the protocol in RFC 7868. We will compare and contrast OSPF and EIGRP in an upcoming video. An OSPF router sends its neighbor routers link state advertisements that contain link state information and metric, also known as cost. The LSAs, which are descriptions of the links connected to the router, are stored in a database known as the link state database. These LSAs are flooded throughout the OSPF domain, just as the originating router received them. Remember that a router does not modify the LSAs it receives. If it advertises an LSA it receives, it does so just as the original router advertised it. Note now that an OSPF neighbor is just a router that shares a common OSPF-enabled network segment. OSPF neighborship is explained in full detail later. All OSPF routers have an identical link state database for a certain area. Single and multiple area OSPF will be explained later, but for now, just know that all routers in Area 0 will share an identical link state database for Area 0. All routers in Area 1 will share the same database, Area 2, so on and so forth. A router will see itself at the top of the shortest path first tree, which is created using these LSAs that are stored in the database. This tree contains all the destinations within that OSPF domain. The shortest path tree is different from every router, but the database used to create the tree is the same. The router then populates its routing table using these trees. Next, we'll take a look at an OSPF topology and then some of the shortest path trees that result from that topology. So here we have a simple topology with 4 routers. This is router 1, this is router 4. This guy over here we'll call router 3. And each router has a network hanging off of it. These numbers here next to the links are the cost, or the metric. All of the links have a cost of 10 except for the serial, which has a cost of 20. More about cost and how it's calculated will be explained later in the course, but for now just know that every link you cross, you add the cost to get to a destination. So to get from here to here would be 30, 20, 30. If you went this way, it would be 10, 20, 30, 40. So here we have the SPT calculated by router 1 and by router 4. Looking at the shortest path tree, it appears there's no redundancy in the network. However, the shortest path tree is the shortest path to a destination. Topology changes will cause the shortest path tree to recalculate and the SPT may change. In the examples above, notice that the shortest path trees for router 1 compared to router 4 are almost the same. However, router 4 chooses the serial link to the 4.4.4.0 network because it has a lower cost. From R1's perspective, the serial link is missing from the topology. From router 4's perspective, the Ethernet link between router 1 and router 3 is missing. Each router sees itself at the top of the SPT, as we mentioned earlier. This is also known as the root of the tree. Pause the video here and take a second to analyze these SPTs compared to the OSPF topology. Maybe go back and take a screenshot of that topology so you can pull it up and look at these side by side. So why did R4 choose the serial link? Well, as we mentioned earlier, if you look, the cost to get there over that link to the 4.4.4 network is 30, so 20, 30. And if you went the other way, it would be 40. The reason R1 chose the Ethernet link is obviously because it costs 20 to get there. So each router knows about all of the links in the topology, but it creates the shortest path tree based on what it determines as the best, shortest loop-free path, which has the lowest cost. You don't necessarily need to be able to memorize in your head the exact way that an SPT would look, but it's helpful to know that this is how the protocol operates. So in conclusion, what have we learned so far? We know OSPF is a dynamic link state routing protocol. OSPF is standards-based, defined in RFC 2328 and 5340. This is for version 2 and version 3, which is for IPv4 and IPv6. OSPF uses IP protocol number 89. OSPF uses link state advertisements to populate a link state database. It then constructs the shortest path tree from the database and then uses the tree to populate its routing table. OSPF calculates the shortest loop-free path to a destination. Link state databases are identical for an area, and routers have a complete picture of the topology. So area 0's link state database for router 1 and router 2 is the same. The link state database for area 1 between router 1 and router 2 are the same, so on and so forth. And what's next? In the next video, we'll go over a basic overview of OSPF areas. Areas will be explained in much more detail later in the course. We'll also compare OSPF to EIGRP to satisfy Encore Exam Objective 3.2a. If you enjoyed this video, consider giving a thumbs up. That'll help me teach more engineers about OSPF. Thanks for watching, and I'll see you in the next video.